Today in the workshop, we'll be working with Matrix Keypads. We'll see how these devices work and how to easily interface them with an Arduino. We'll even construct a digital combination lock with an LCD display. We're in the Matrix today, so welcome to the workshop. Well, hello and welcome to the workshop, and I hope everyone is doing well. Now today we're going to be working with a very simplistic component that is nonetheless very useful, and that is something called a Matrix Keypad. A Matrix Keypad can be used as an input device for your Arduino projects, and as an input device it can provide a very nice looking interface that is very inexpensive. The keypad I'm using is literally less than $1 in cost. Now a Matrix Keypad is very valuable when you have a number of input push buttons that you need to use on your project. Normally we would wire a push button to an individual input pin on the Arduino, and so for every push button we would need one pin. Well, with a Matrix Keypad you need less pins because these are being worked on an XY matrix as opposed to individual button connections. Now it's not useful for every application. If you have less than 5 switches that you need to add to the Arduino, you're not going to save any connections. And when you go above 20, there are better ways of doing this, such as using the serial port and a full-size keyboard. But for a number of applications, a Matrix Keypad is going to be ideal. Now what we're going to do today, of course, is examine how the Matrix Keypad works, and then we're going to hook it up and just give a simple demo to make certain that we can work with it. I'll show you a library that makes it very easy to work with this device. And then after that, we're going to build something. We are going to build a combination lock, which is a very common application for one of these keypads. So let's go and take a look at how these keypads work. A Matrix Keypad is an arrangement of push-button switches connected in an XY matrix. These keypads can make use of standard push buttons or plastic membrane switches. Pressing a button will connect the X and Y conductors that the switch is connected to. Only one key press at a time is recognized with this arrangement. The Matrix Keypad is a very common input device. Now here we have an illustration of a 4x4 matrix with 4 rows and 4 columns. A push button is mounted at the junction of each of the rows and columns, and pressing the button will connect the row to the column. Initially, the rows are set as being outputs and are held down at a digital 0 or a low condition. The columns are inputs and are held high or a digital 1. When a button is pressed, it connects to 2 conductors, and the column that the button is on will now go to 0. In order to determine the button's row, the columns are now held down at 0, and the rows are individually scanned by bringing them up to digital 1. When the row that the button is connected to is scanned, that will cause the column output to go to digital 1. By doing this, we now know both the column and row position of the button that was depressed. There are many types of Matrix Keypads, but for experimenters there are 2 very common ones, the 4x3 matrix with 12 buttons and the 4x4 matrix with 16 buttons. Either of these devices can be used in our experiments. And so now let's start working with Matrix Keypads. Now this is the keypad that I'm going to be working with today, and this is one of the 4x4 keypads, and as you can see it's got a pretty standard layout. This is actually a standard telephone layout. I don't know if a lot of people realize that when they define the DTMF tones, the dual tone multiple frequency tones for telephones, which some people call by the trade name touch tones, there actually were 16 of them and not 12 of them, but most telephones of course didn't have the A, B, C, and D keys on them. That's a little bit of trivia for you. As you can see, this is a pretty simple device. On the back of it over here, it's just basically a plastic backing, and you could actually stick this down onto the panel of your project. So it's actually a very easy thing to work with. Now it's got this film ribbon cable coming out. In actual fact, there are two of these cables, if I can just separate them for you, as you can see over here. And this cable here are the column connections, and here are the row connections. And the connections are quite simple. If you just go along the bottom of them over here, the first four are the rows, row 1, 2, 3, and 4, and then columns 1, 2, 3, and 4 connected over here to this female 8-pin DuPont connector. Now, if you happen to be using the 12-key version of this, the 4x3, which won't have these keys on the side over here, all that will happen is that this will be a 7-pin connector, and the column will be missing the last connection, but otherwise it'll be identical. And so these inexpensive devices are great input devices for the Arduino. So now let's go and see how we can actually use them. So now that we've seen the keypad, let's begin working with it. Now, in order to simplify this, we are going to be using a library, which unsurprisingly is called the Keypad library, and it's one that you can install through your Arduino IDE. So let's go and hook this up, install the Keypad library, and do a very simple demonstration just to make certain that our keypad is functioning correctly. To get started with our keypad experiments, I'm going to be using an Arduino Uno and a 4x4 membrane keypad. Now you can use a 4x3 keypad if you wish. The connections to the Arduino from the keypad are very simple. Row 1 is connected to pin 9 of the Arduino's digital I/O. Row 2 to pin 8, row 3 to pin 7, and row 4 to pin 6. Column 1 is connected to I/O connection 5, column 2 to 4, column 3 to I/O connection 3, and column 4 to I/O connection number 2. Now, if you're using a 4x3 keypad, you can eliminate that last connection. So now that you have this set up, let's go and take a look at the code we can use to test out our keypad. Now, coding for the keypad is simplified by using a dedicated library called the Keypad library. So before we get started, we're going to need to install that library. So in your Arduino IDE, go up to Sketch, go into Include Library, and then go to Manage Libraries. This will open your library manager. Go into the Filter Your Search box and type in the word Keypad. You'll get a number of results. Scroll down because we're looking for an actual library called Keypad. And this is it over here by Mark Stanley and Alexander Breivik. Now, I've already installed mine, but you'll have an install button if you haven't done that. So install this library, and then we'll be ready to run our code. Now here's our simple demonstration code, and as you're going to see, the Keypad library makes it very easy to work with the keypad. Now the first thing we do, of course, is include that library in our code, and then we're going to make a couple of constants, one for rows and one for columns, and this just tells us how many rows and columns you have. Now if you happen to be using a 12-key keypad instead of the 16-key keypad that I'm using, change the columns to 3. Over here, we are going to be making an array with both rows and columns. And so each one of these elements in the array is the rows, and it gives a list of the columns. Again, if you're using the 12-key keypad, you're going to be leaving off the last entry in these. Next, we define the connections to the Arduino, and once again we do this in an array. As you're going to see in a moment, the reason for using arrays is that's what the Keypad library wants. And so these are the connections on the Arduino to the row pins, and these are the connections to the column pins. If you decide for some reason to use other pins, you'll just have to modify that part of the sketch. Now we actually create a keypad object, and the keypad object is made using the keypad library, and we'll give it the following parameters. We're going to do a make key map, and then we give it the hex keys, and the hex keys were the ones that we gave it up over here, that array there, and the array of the row pins, the column pins, and then the number of rows and columns. So all of the things that we've defined before this statement are included over here. In the setup, all we are doing is setting up our serial monitor, because we're going to be using that to monitor the key presses, and then we go into the loop, and as you're going to see, it's very simple. We have a character variable called custom key, and that's going to be using the getKey method of the Keypad library. So if we actually have a keystroke, it is going to be passed back to this character called custom key, and then we are just going to see if custom key exists, and if it does, we're going to print it to the serial monitor. We're using println so that there'll be a carriage return and line feed after each entry, so these will appear on one line at a time. So it's a very simple program. Let's go and see it in action now. Now here's our first demonstration with the keypad, and the components are pretty easy to see. It's the keypad and the Arduino, and of course we're going to bring the serial monitor up so that we can monitor the keypad output. Now you'll notice that I used some cables to connect the keypad to the Arduino, and what I used is one of these ribbon cable things over here, and these are great because you can just separate off as many wires as you want. So I took 8 of them out and just hooked them up over to here and hook them over to the Arduino. It was a very easy way to do it, especially as there's kind of a 1-to-1 ratio. These connections here are in the same order that they are in the Arduino. So now that we've got it hooked up, let's just see that our keypad actually works. So I'm going to press some keys on the keypad, and as you'll see on the serial monitor, that key is being displayed up on the monitor. And although it's a basic test, it really illustrates how we can code for the keypad input, and that's a very important thing to be able to do, of course, in order to use the keypad in our experiments. So now that we've determined that the keypad is functional, let's add a liquid crystal display to the circuit. And this will essentially take the place of the serial monitor in the last experiment and give us some feedback as to which keys we've pressed. Now I'm going to use a standard 16:2 LCD display, and I'm going to use one with an I2C backpack to decrease the number of connections to the Arduino, because I've already used up 8 connections for the keypad. Now one thing that's slightly different about this from all the previous times that I've used LCD displays is that I'm going to be using a library that is specifically made for liquid crystal displays with I2C backpacks. So let's go and take a look at how we install that library and how we simply hook up an LCD display to our circuit. We'll begin this experiment with the same connections that we had for the previous experiment. We're going to add a liquid crystal display with an I2C backpack. We'll connect the display as follows. The Arduino's ground connection will be connected to the ground connection on the display. The 5-volt output from the Arduino is connected to the VCC of the display. Arduino pin A4 will be connected to the display's SDA connector. Pin A5 will be connected to the display's SCL connection. So now let's look at the code we can use to add the LCD to our circuit. Now in order to use a liquid crystal display in our sketch, we're going to need to use a library for it. And there are many libraries you can use for LCD displays. The one I'm going to use today is a liquid crystal library that is specifically made for displays that have an I2C connection. And this is not a library that you can get directly through the library manager. You're going to need to install it yourself. And so you go over to GitHub, and I'll have to link to this in the article accompanying this video, and you'll find the library over here. You can clone or download the library. I would download the library, and it will be a zip file that you can save on your local hard disk. After that, go back into your ID, go up into Sketch, and do Include Library, and do Add Zip Library. Navigate to wherever that you have downloaded it, in my case the download directory, and go and select it and install it. Now mine is the Liquid Crystal I2C master.zip, and that's this one over here. And so I would install that and say, okay, I don't need to do it because I've already done it, and that should install the library. Once you've got the library installed, we can look at the sketch, which as you'll see is very similar to our last sketch. Now we're going to include a number of libraries. First of all, the wire library, which is the built-in library in your IDE for dealing with I2C connections. Then we'll include the library we just installed, the Liquid Crystal _I2C library, and of course the Keypad library we used before. Now the beginning of this sketch is identical to the old one. We define a few constants for rows and columns. We make an array to determine what the actual values of all the different buttons are. And then we define the connections to the Arduino in two arrays, just as we did before. And then we create a custom keypad object the same as we did before. Now we need to also create an object for our LCD. And we're going to call the object LCD, and we're going to give it the I2C address, the number of rows, and the number of columns. Now, the I2C address on your display may be different than mine. Mine is hexadecimal 3F, but if yours is different, of course, you'll have to change that part of the code. In the setup, we're just going to simply set up the LCD display. We'll set it up with a backlight, and then we'll initialize it. And then the loop is very similar to what we saw before. If a key is pressed, it's going to populate this value of custom key. And then if we actually have a value for custom key, we're going to clear the LCD display, set the cursor to the very beginning at the top on the first row, and we're going to print the value. And so again, a very simple sketch for demonstrating the operation of our keypad, this time using an LCD display as an output. And so here's our demonstration with the Liquid Crystal display and the keypad, and I think the components here are fairly obvious. This is the keypad, the Arduino, and the LCD display. Now this is the LCD's backpack, the I2C backpack that I have on the display, and normally of course this would be inserted on the rear of the display, but this is my experimenter's display, and I've put it on the front because I find it a lot easier to access it and also to control the brightness, which is what this little pot does on the display when I've got it on the front. So it's just for experimenting purposes. You'd naturally want to put yours behind the display. But it's very simple to demonstrate this. I just hit a key on the keypad, and as you can plainly see, that key is also being displayed on my Liquid Crystal display. So really what's happening here is the display is just taking the place of the serial monitor that we used in our last experiment. So not really that much of a amazing thing to see, but it does show you how you can use both the Liquid Crystal display and the keypad in your project. And these are two components that you'll probably be using together in a lot of different projects. Well, now that we're experts on using a Matrix keypad, let's build something practical with it. And what we're going to put together is a combination lock, or a combination entry pad. Now, this can actually be used in a real-world application where you would drive a solenoid that would unlock a door or a drawer or a cabinet or something. And in that application, what you need to do is apply voltage to the solenoid for a brief period of time, about a second or so, enough to allow the device to be unlocked. When the power is turned off the solenoid, it goes and locks itself again. Now in our demonstration, I'm not going to be using a solenoid, I'm just going to be using a lamp, but you could very easily wire a solenoid of any voltage into the circuit because I'm going to be using a relay to drive that lamp. And so let's go and take a look at the hookup for this experiment, and then we'll take a look at the code. For our combination lock, we'll start off again with the same circuit that we had before with the keypad and the LCD. We're going to be adding a small relay module to this circuit. This relay module will be used to control a locking mechanism such as a solenoid. For simplicity's sake, I'm not going to be showing the locking mechanism or its power supply. I will assume that you can just connect this to the output of the relay. The connection to the relay module is very simple. We'll connect the ground connection of the module to the ground connection on the Arduino. The module's VCC connection will be connected to the Arduino's 5-volt output, and the module's trigger or signal connection will be connected to pin 13 of our Arduino. Again, I will not be showing the connection to the locking solenoid or its power supply. Once you have that connected up, we can take a look at the code we'll use for our combination lock. Now here's the sketch that we're going to be using for our combination lock, and I got most of this sketch from an equivalent sketch on circuitbasics.com, who also have an excellent article on using these keypads. Now our sketch is going to start off the same as the previous one. We'll include the wire library for working with I2C, the liquid crystal I2C library for working with our display, and the keypad library for working with the keypad. Then we need to set up a constant that indicates the length of our password, and this constant actually has to have a value of 1 more than the characters in our password. So I've set mine up to 8, which means I have a 7-character password. The extra digit is being used for a null character. Then we'll create an array to hold all of the data of the password, and we set that to the size of password length. So we're calling the array data, and we'll call another array master, and this is the array that is going to hold the actual password, and we'll populate it with these values over here, which is the password. Now these are just the first 7 characters on the keypad, so it's obviously not a particularly good password, and you'll want to change that to something a little bit more difficult to guess in your application. We'll define a pin to use as the output for the relay. Now I've used pin 13 because I liked pin 13 simply because it has an onboard LED in the Arduino, which I could use for troubleshooting, but you could really use any pin that you wish for this. Now we define a byte over here that represents the count of the number of characters that we've entered. We call it data count, and we initialize it to 0. The custom key character variable we've seen before. This is the one that simply holds the characters that come in from our keypad, and we set the keypad up as we did before with the rows, the columns, the array that represents all of the different values of the keys, the arrays that represent the connections, and then we create a custom keypad object just as we did before. We'll also create a custom LCD object just as we did before, giving our I2C address and the fact that it's a 16:2 LCD display. And of course you would change that for using a different type of display. Now in the setup, it's quite simple. We just go in and set up our LCD. So we initialize the backlight and initialize the LCD itself. And we'll also use the pin mode to set the output pin, the lock output, up as an output. And then we go into our loop. And in the loop, we're going to start off by initializing the LCD display and putting it at 0.00, in other words, at the very top left corner, and we're going to print enter password on the display. And then we're going to look for a key press. Now, if we get a key press over here, the value of custom key will have a value, and then we'll go in and we'll enter that value into the array called data. We'll put this also and print it onto the LCD, and then we'll increment the data count so that the next time this happens, we can add this to the next position in the array. So we'll continue to populate this array. We'll have to see if we've reached the password length, and if we have reached the password length, which is the password length constant -1, then we know we've entered the entire password. So we'll clear the liquid crystal display and compare the data array to the master array, the data array being what we entered, the master array being the one that holds our password. If they do compare identically, then we'll print out correct on the display because we have had the correct password, and we're going to turn our relay on for 5 seconds. So we go and do a digital write and write it high to turn the relay on, delay for 5 seconds, and then turn it off. Now the 5 seconds is going to be variable. If you have a locking device that requires more or less time to be on to unlock, you can change this value over here. If the password isn't correct, we'll just print incorrect and delay for 1 second. At any rate, when we finish all of this, we're going to clear the LCD display and clear all the data from our array as well. We clear the display with an LCD clear, and we clear the data by calling a function we call clear data, which you'll see right below here. And that simply iterates through the array and sets all the values up to 0. And so when you get down to it, it's not that difficult to sketch. Let's go and see it in action now. Alright, here's our combination lock demonstration all ready to go. Now, as you can see, I've got, of course, the keypad, the Arduino, and the LCD as we've had before. I added a small solderless breadboard just to distribute the positive 5 volts because the Arduino only has one 5-volt output. I've just used the 2 different ground connections for both the relay and for the LCD display. Now, this is the relay module, the one that's being driven from pin 13 of the Arduino, and on the other side of it I have connected this lamp, which is being driven by my bench power supply, but this of course could be replaced by a solenoid locking device, and the lamp just basically is a little bit easier to see visually right now. So I'm going to start off, we'll look at the display while I enter in an incorrect combination. And it tells me that it's incorrect and goes back and asks me to enter the password. So now let's enter the correct one. And it activates the relay, and it should only be activated briefly, and there you go, it turns off, and that's normal operation. If you're driving a solenoid, you would drive it so that it allows access to the location, opens a door or a drawer or whatever you're opening, and just does it for a couple of seconds and then closes off. In fact, a lot of those devices you can't apply power for more than 10 seconds or you'll burn them out. But as you can see, this is a very usable circuit, and you could put this into an enclosure with a solenoid lock and build a practical electronic combination lock with it. And so as you can see, a Matrix Keypad is a very simple device to work with, and yet it can provide a very useful input interface for your Arduino projects. Now, if you would like to get more information on the Matrix Keypad, or if perhaps you'd like to grab the code that I was using today, then just head over to the DronebotWorkshop.com website, where you will find an article that accompanies this video, and you'll find a link to that right below the video in the description. While you're on the website, please consider joining the newsletter if you haven't. The newsletter is just my way of keeping in touch with you to let you know what's going on in the workshop. And if you want to discuss the keypad, well, head over to the DroneBot Workshop forums at forum.dronebotworkshop.com. We've got a lot of great people on the forum that can help answer your questions about any of the problems you're having with your projects, or just engage in some discussions about technology with like-minded individuals. Now, of course, if you haven't subscribed to the YouTube channel, I would be very thrilled if you would do that. And all you need to do is hit the subscribe button. But after you hit it, also hit the little bell notification, and that way you'll be notified every time that I make a new video. So until we meet next time, please take good care of yourselves. Please stay safe, stay isolated, learn to cut your own hair like I'm doing, and probably do a better job than I'm doing. And I hope to see you very soon here in the workshop. Goodbye for now.